Now we're going to solve a whole bunch of proportions. When you are solving proportion word problems, you need to read the problem and figure out what two things are being compared. And then you're going to set up your fractions to represent those two things. It doesn't matter how you set up the fractions as long as you're consistent within the problem. So consistency is key on these problems. So let me show you 5 different examples and how you would set them up. So the first one says if there's 3 cars for every 8 students at a high school, how many cars are there for 1,200 students? So as you read the problem, you can see they're counting cars and they're counting students. So those are the two things that we're going to be comparing, is cars to students. So you have to make a decision at the beginning of the problem. Are you going to set up your fraction as cars divided by students, or are you going to set it up as students divided by cars? It makes no difference. You just have to pick one of those and stick with it through the whole problem. So I'm going to do it as cars divided by students. I'm just going to choose that way. So let me read the first statement here. There are 3 cars for every 8 students. 3 cars, 8 students. That's the first thing that they just told me. And then it says, how many cars, we don't know, how many cars will there be for 1,200 students? Okay, well, where does the 1,200 students go? It goes in the denominator. And the how many, I don't know how many cars, so that's where I'm going to put my variable. So what will happen is they will give you one full fraction, and then the second fraction, one of the parts will have a variable in it. And how do we solve these? We cross multiply. So I'm going to start with the diagonal that has the variable in it. So that's going to be 8x equals the other diagonal. 3 times 1,200, 3 dozen is 38, so this would be 3,600. And then to solve that, you could divide both sides by 8. And if you take 3,600 and you divide by 8, it actually turns out nice, and it's 450. 450 what? The x was on the top, that's cars. So how many cars are needed for 1,200 students? There'd be 450 cars. Okay, so we did cars to students. Just make sure that you're consistent. The next one says, if a recipe calls for 9 eggs to make 4 batches of cookies, how many eggs are needed to make 30 batches of cookies? So it looks like they're comparing eggs and batches. So I'm just going to, the way I read them, that's generally how I set up my fraction. Just the first thing I read about, eggs, goes on the top, batches goes underneath. So 9 eggs to make 4 batches. How many eggs? I don't know. So the top is going to be an I don't know, to make 30 batches. And that should be a fairly easy proportion to solve. So start there, 4x equals the other diagonal, 9 times 30, and 9 times 30 is 270. And then what we're going to do, divide both sides by 4. And you can use a calculator if you need to. 270 divided by 4, 67.5. Okay, I'll let you do a decimal if it's just a 0.5 at this point. And how do you get half an egg? I don't know. Y'all figure that out on your own. I don't know what to tell you for that one. You probably just use 67 or 68. You're not going to actually cut the egg in half, but whatever. It's possible that you can get decimal answers. So there's a recipe. That's actually a pretty common usage of proportions, is converting, like making more of a recipe or making less of a recipe. That's a pretty common application. All right, how about the next one? A grasshopper can jump 20 times its length. If the jumping ability of humans was proportional to grasshoppers, how far could a 6-foot-tall person jump? So we're comparing how big the animal is compared to how far it can jump. So it's the height of the animal versus the height of how far they can jump. So the first one, it's a little sneaky on this one. A grasshopper can jump 20 times its length. They didn't tell you how big the grasshopper is, but they said it can jump 20 times its length. So let's just create a fraction for that. What if it was a 1-inch grasshopper? Then it could jump 20 inches. Isn't that the simplest one to set up? I don't need to do any math. A 1-inch grasshopper could jump 20 inches. So that means a 6-foot-tall person, that's the height of the animal here, the person, 6 feet, how far could they jump? How far could they jump? So the variable goes down in the bottom. So a 1-inch grasshopper could jump 20 inches, a 6-foot person, well, I don't know, let's see. That's going to be one diagonal. This is going to be the other one. So we have 1x, which you don't really have to write the 1, equals 6 times 20. So actually there's nothing to solve here. That would be 120 feet. Y'all think about this. This is what's going to make you appreciate the grasshopper. If a grasshopper can jump 20 times its length, that would be like a 6-foot-tall person jumping 120 feet. That is a massive amount. So 20 times what the person's height is. That's how you would set that one up as a proportion. That one, a lot of times also students just sort of think about it and come up with the answer. But if you needed to write it as a proportion, that's how you would do it. Now the rest of these are, they're ratios, they're still proportions, but we're going to work them a little bit differently because you've got more than 2 things that are being compared, or 2 people that are being compared. So it says, Kirk, Ryan, and Matt worked mowing lawns. The hours they worked were 6 to 3 to 5 respectively. That means, respectively means these numbers go in the order of the people. So we've got Kirk is first, Ryan is second, Matt is third. So 6 hours, 3 hours, 5 hours respectively. They were paid a total of $252 and divided the money in proportion to the number of hours worked. So if you worked more hours, you got more of the money. How much did each person earn? So I decided maybe a visual for this so that we don't have to work it out necessarily in a super mathy way, but we can do it with a visual, is to actually just put hours for each person, like I made a chart. So Kirk, that was 6 hours, Ryan, 3 hours, Matt, 5 hours. So 6 to 3 to 5, that's what we're comparing. So we got to divide up the $252. You don't just divide it among 3 people. You have to consider how many hours. So we do need to look at the total number of hours. And if you just count my little clocks here, 6 plus 3 plus 5 is 14 total hours. So we're going to divide this up per hour. So 252 divided by 14 total hours. If you divide that, you get $18 per hour. Each one of these little clocks is 18 bucks, right? Each one is 18 bucks. So let's figure out for Kirk. If each clock is 18 bucks and there's 6 of them, that's 18 times 6. 18 times 6 is 108. So Kirk's going to get 108 bucks. For Ryan, he only worked 3 hours at $18 an hour. So 18 times 3, that's 54 bucks. And then we got Matt. And Matt worked 5 hours. 18 times 5 is 90 bucks. And if you add these up, this is one way you can kind of check your answer. The total should be 252, but we're dividing it up proportionally. But do you see how I'm not setting this up as like an equation like we did these previous ones? This one is set up a little bit differently. So how much did each person earn? That's what this is. So right here, this would be, I guess, your answer. How much each person earned. Kirk earned 108, Ryan earned 54, and Matt earned $90. It's based on the total. So let's try one more. Arnold, Barbara, and Caleb have pet fish in the ratio 4 to 5 to 7, respectively. There's that word again. So that means the 4 is Arnold, the 5 is Barbara, the 7 is Caleb. Caleb has 21 more fish than Arnold. How many total pet fish does each person have? So again, this is a graphic. I decided to use a fish. I thought it would be a cute graphic. Each fish does not necessarily stand for one fish though. Like it could be multiple fish for each of these. So it says Caleb has 21 more than Arnold. Well, let's compare Caleb and Arnold. Let's kind of leave Barbara out of it for right now. Let me cover that up. If you compare Arnold to Caleb, there's 3 more fish here, right? We had 4 to 5 to 7. So there are, if you compare, these are the extra ones that Caleb has compared to Arnold. And that is 21 more. So these 3 right here is 21. This represents 21 fish. So what does each little fish stand for? Like each little picture of a fish, if there's 3 of them here and that stands for a total of 21, then each little fish icon that I have, we'll say it's like that, is equal to 21 divided by 3 is 7. So 7 fish. So Arnold has 4, Barbara has 5, Caleb has 7, but each little fish picture that I put on here stands for 7 fish. So let me get this where y'all can see. So for Arnold, 7, 7, 7, 7. It's just 7 times 4. He has 28 fish. That's what Arnold has. Barbara, 1, 2, 3, 4, 5 fish. But each one of those fish stands for 7. So that would be 35 fish. And Caleb, he's got 7. 7 times 7 is 49 fish. So the question is, how many total pet fish does each person have? So now we know. And you can double check that Caleb's 49 is actually 21 more fish than 28. That's how many Arnold has. So each picture, you have to figure out what each picture is worth. And the kicker was the fact that they told us that Caleb had 21 more fish than Arnold. So we could compare it based on our picture. So that's proportion word problems.